Third, define a target. So my target will be to minimize the square difference in the value calculated by my model minus the observed value. In this case, the observed value is this one here. This is the number we already have and the number we want to reach. Now, define constraints if any. No constraints for now. And start solver. Use default settings. So in these cells, I'll go ahead and write some information so we don't forget about it later. So formula. So my formula is this one. I'll just go copy and paste. Decision variables, PV. Other variables, R, N, and T. Do I have all these values? Yes, I do. R equals 8%, N equals 12, and T equals 30. Now, my observation, FV, and the value my model will calculate. I'll call this FV hat. And now, my target. Target will be FV minus FV hat squared. Now I have to go ahead and actually enter the formulas here. So FV equals this, the same value as cell B2, and FV hat equals, okay, sorry guys, I'll go ahead and insert 2 more cells here, and I'll enter PV with initial estimate of $1,000. Now, F hat equals present value times. Now I just have to copy the formula one more time. 1 plus R divided by N to the power of N times T. And that's it. I have my model, I have my model, I have my observation, I have my decision variable, and I have my target. Now, so if you cannot find solver here under the data label, you have to go to File, Options, Add-ins, Manage Excel Add-ins, go. And here you should be able to install solver. If you can't see the solver option here, or you're not able to check it, maybe the Excel version you're running does not support solver, and in this case you're out of luck. Unfortunately, there is nothing you, unless you want to buy solver from Microsoft or buy a different Excel. Okay, so once we have solver installed, let's go ahead and click here, and we get this window here. So set objective, the first one, we'll go and click here and select our target. Set objective, this cell to minimize by changing variable cells. Make sure you pick this, your decision variable cell. Subject to constraints, none, and remember to leave all the other settings as default. As much as you want to check how this works and see all the options you have using solver, for now let's keep it simple, guys. We have our objective, we have our decision variables, we do not have constraints at this time. Before starting the algorithm, let's see the problem we have at hand and what we expect solver to do. So we have this target, this is a very high number, 9 times 10 to the power of 11, and solver's goal is to minimize this, which will effectively make this value as close to this value as possible by changing the cell number G7 or PV or decision variable. And what do we expect? We expect that this PV will go all the way to 91443.4, because this is the real result of this problem. And let's see if our expectations are met by solver. Keep solver solution. Okay. And there it is, guys, exactly the same number. The target goes all the way down to 0, so I can say with confidence that these numbers are exactly the same to the precision of my computer. And that's it, guys, we did it. So let's go ahead, copy and paste this value here. There you go. There you go. Now you guys can, as an exercise, try to do the same for PMT. See if you're able to reach the same results. Once you're ready, let's go ahead and make things more interesting. Okay guys, so let's study some different scenarios now. The first one, instead of 30 years, I want to retire in 15 years. How much would I have to save every month throughout these 15 years to reach the same amount of $1 million? In the second scenario, I want to calculate the return rate, or R, considering that my investment goal is 1 million and the PMT is the same one as I get in the previous scenario. What kind of return rate do I need to make this objective come true? And finally, in the third scenario, I want to calculate the time for a 1 million goal at a 10% return rate a year, considering that I can only save 1,000 every month. How long would I take to reach this goal? And we will practice using solver in all of these scenarios. Observe that I want to calculate PMT, so my model is the second one. To make things a little bit easier here, instead of copying and paste this formula one more time over there, I'll go ahead and go View, make sure I'm selecting this cell, Freeze Panes, and select Freeze Panes. So now every time I move to the right, I'll always be able to see the first column in which I have my formula. And what did I do? I just froze the panes. Now let's follow those 5 guidelines to use solver. First one, define my model. It's on cell A8. FV equals PMT times open parentheses 1 plus R to the power of T minus 1 close parentheses divided by R. Here I have this N because the periods are equivalent to monthly deposits. So instead of R, I use R divided by N, and instead of T, I use T times N in my model. So the first step done, have the model. Now decision variables, just PMT. Third, what's the target? So here the target is also a future value of 1 million. So I will go down and create this cell as FV hat, which is the future value calculated by my model. Now fourth step, I'll calculate the target. Equals model minus observation squared. So my initial PMT guess will be 500. Now I use my formula to calculate my FV estimate, equals PMT times. Now guys, I'll just copy the formula in cell A8, okay? Make sure you get all the parentheses so you're calculating the right amount. And there you go, guys, have my model here, and with this initial guess of saving 500 a month for 15 years and investing it at an 8% return rate investment, I would get 173,000. But I want 1 million. So let's make solver work for us here. Go data, solver. Now set objective, target, by changing variable cells. This one, PMT. No constraints, all the other settings as default, solve. Keep solver solution, okay. And there you go, guys. We got a target of 0 And our periodic payments is $2,889.85. If we invest this amount every month for 15 years at an 8% investment, we will get the total of $1 million. Cool, right? Alright, let's go ahead to the next scenario. Now the PMT is the same as before, so I'll go ahead and copy and paste this value here. And I want to calculate the return rate so I can have 1 million after 20 years depositing this amount every month. Now how is this going to work? This is a little bit different because we do not want to calculate the PMT, we want R now. But if we follow our 5-step guideline, this will be easy, guys, I promise you. So let's go. First, the model equation in cell A8. Second, the decision variable R. Third, define the target. So the target here in the scenario is also to reach 1 million after 20 years. So I'll go ahead again and create this cell FV hat, and the target equals FV hat minus FV squared. Now I will use my model to calculate FV hat equals PMT. Observe here that I'm actually using the PMT value. I'm not using PMT as a decision variable. So I'll just enter this value in cell P5 times divided by N. And that's it, guys. I got an error here because I don't have any estimate, right? So I'll just go ahead and enter 5% as my initial estimate. So what am I saying here? If I invest this amount for 20 years every month at 5% interest rate every year, at a 5% yearly interest rate, I'll get actually a lot of money. This is more than our goal. It's 1,187,000. Pretty cool, right, guys? But I want exact 1 million or as close to it as it can be. So when I run Solver, I'll probably get a value lower than 5. Let's see how much it is. So now that we are all set, let's make Solver work for us. So set objective as a P10 or target, and by changing variable cells, P8 or decision variable. No constraints and default settings. Let's see what happens. Okay, so R went to 0 and I got this divided by 0 error, and it says here that Solver encountered an error value in the objective cell or a constraint cell. So in this case, Solver failed in optimizing my problem. And why did it happen? Well, in order to figure this out, I have to go through the problem again and see if I wrote down the formula correctly here. So double check everything. So I already did it, and I'm sure that I didn't make any mistakes, but I still get this error. And here is the divided by 0. So this means that at some point in time, this value here is being divided by 0. So what can cause this? This P8 divided by P4. So P4 is 12. It's never going to be 0. But P8 is my decision variable here. And it shows that it's going to 0. So I'll get this error. And what can I do to fix it? Guys, let's add our first constraint. So I don't want R, the return rate, to be 0, because otherwise this would cause an error in my formulas. And how do I set this constraint? So cell reference R greater or equals to 0.0001. This is greater than 0, right? So it's all good. Now let's see if Solver can deal with that. And solve. There you go, guys. Now I didn't get an error. I was used to get zeros in this target cell, meaning that I got an exact match. But here I got this 1.34262 e minus 11. And what does this number mean, guys? So e minus 11, this means 1.34262 times 10 to the power of minus 11. And how small this number is, and how close to zero this number is. And this means that my FV hat got pretty close to FV. The difference is only 10 to the power of minus 11, which is pretty small. So I can say that solver worked and I got the result I wanted. So my return rate, let me add some decimal places here. 3.48. So all I need is an investment with a 3.48 yearly return rate to get $1 million in 20 years by depositing almost $3,000 every month. Okay, this periodic deposit is quite high, but still this return rate is quite low. So in this scenario, why would I take a lot of risk investing in stocks, for example, if I don't need it? I can just invest in bonds or other lending investments in order to reach my financial goal. And now let's see our final scenario. I want to calculate the time to reach $1 million in an investment with a 10% yearly return rate. So let's follow our 5-rule guideline again. First, my model, again in cell A8. Second, my decision variable, time. Third, let's define the target. So again, the target will be FV hat, and then target equals FV hat minus FV 1 million squared. Now I use my model to calculate FV hat. So just copy the formula, making sure all the parentheses are correct. So FV hat equals PMT times 1 plus R divided by N to the power of time times N minus 1 divided by R divided by N, close parenthesis and close parenthesis. Okay, I think I have an extra parenthesis, but Excel just fixed it for me. For an investment of 5 years, depositing $1,000 every month at a 10% return rate, I'll get $77,437,000. But this is not how much I won. I won 1 million. And how much is that? Let's see, solver. How much is that? So set objective, target, by changing variable cells, time. Here I still have this leftover constraint from the previous scenario, so I will go ahead and delete it. And all other settings as default and solve. And there you go, guys. 22.42 or 22.43 years to get 1 million by investing 1,000 every month at a 10% yearly return rate. Pretty cool, right, guys? So in this video, we learned to model our scenarios and solve nonlinear equations in Excel using 3 different methods. First one is the algebraic manipulation solution, which might not be useful if the problem is too complex. Then we learn 2 numerical methods. The first one is the extensive calculations. So we evaluate our function at different points in our decision variable to see how close we get to the value we actually want. And we keep refining this until we get close enough. And finally, we learned the third, and in my opinion, the And finally, the third method, which is based in the solver algorithm in Excel. We learn to follow those five. We learn to follow that five-step guideline. Step number 1, define your model. Step number 2, define your decision variables. Step number 3, define your target. Step number 4, define your constraints, if any. And step number 5, run solver. But remember guys, the most important thing, always check your solution and see if it makes sense, because algorithms are tools. They will make our life easier, but they will not think for us. We are responsible to do the thinking. And that's it. Thank you very much for watching, and see you guys again soon. Hope you enjoyed the video and were able to learn something from it.